This is defense number 2 for Erin McCaffrey defending the MAST lesson plan, and the unit that I was teaching was Introduction to Photosynthesis, which is part of the photosynthesis unit, and the measurable student outcome for my unit was that 80% of students were going to leave the classroom with confidence and mastery of the learning target, which was to describe the flow of energy through living things and photosynthesis. After my first unit, when 80% of students failed their first test, I began implementing MAST methods in my second unit, where I slowly brought in JTPS and a more structured active practice and interactive mini lecture. There was an improvement. The average from the 3 quizzes I gave during the second unit was that 65, 93, and 42% of students passed, which is much higher than the 20% from the first unit. Through implementing the MAST aspects more often and more thoroughly, I hope to have 80% of students pass the summative assessments from this unit. Before we started the lesson, I had them all write down what their goal would be for the unit, and I had various responses from things like very grade-based, like my goal is to not have an F by the end of the unit, to I will get A's on everything, to that were more learning-based, like I will pay attention, or I will learn everything I can about photosynthesis. And I think that it's important to have them write their goals down and reflect on them later. That way they can see if they're actually achieving what they had hoped that they would. The first part of the lesson was a hook, which was showing a YouTube clip of a Venus flytrap eating a fly. This was used to bridge the students' knowledge of pop culture or a Venus flytrap eating a fly and the concept of plants acquiring energy and how they do this. Research has shown that hooks help link short-term memory and long-term memory, which may help the students more successfully remember the content. After showing the video, and talking about do plants eat, where do they get their energy from, we moved into an IBE, which had students drawing the flow of energy through photosynthesis before we moved into the content. D'Alessandris has shown through research that one way to use IBEs is as a goal-free problem with no explicitly stated unknowns, which is what this was, just draw photosynthesis. They had to draw on prior knowledge of energy and food chains and photosynthesis while leading us directly into the active practice, into the interactive mini lecture. And 100% of students got the basic idea of sun shining down on plants and giving them energy, although only 10% drew more than that. And the interactive mini lecture covered an introduction to photosynthesis. The interactive mini lecture is important because research has shown that interactive lecturing can open up the lesson to a dialogic form of learning and higher cognitive thinking. We began with a JTPS about the basic concepts of photosynthesis. After observing in Claire's classroom, where I saw JTPS in action, I saw that it can be very successful, but that it takes some practice to implement. And because of this, I explained in detail how students should fill out the MAST JTPS template, as Clara did. And research by Maher has shown that the justification that's required during JTPS can result in more sophisticated thinking due to the reorganization of their thoughts that's necessary. After my JTPS this time, I realized that my questions were not ideal, as a lot of students answer them as yes or no, which I didn't realize would happen. And so I, in the future, will make sure that I am using questions that are how or describe rather than does this happen, because they didn't think that they had to justify anything. And 50% of students chose to answer them as yes or no rather than justify. And after that, I moved into the PowerPoint, and into the PowerPoint, I had mixed in formative assessment questions using mini whiteboards. And research by Black and William has shown that formative assessment can increase student knowledge and improve understanding. So formative assessment is very important. I decided to use whiteboards because I saw them in use during my observation in Claire's classroom. I found that at least 80% of her students were engaged in participating. And actually, while using the whiteboards in my classroom, 100% of students were engaged in participating. They really enjoyed the privilege of using the whiteboards, and I hope to use it a lot more in the future. And while I designed the questions to be easy and they did work in groups, 100% of the students answered the formative assessment questions correctly. In an ideal world, they would each have their own whiteboard rather than working in groups. However, I do not have enough whiteboard markers for that. Also, in the future, I will start off with very easy questions simply about rebounding content back. However, I hope to also use questions that require them to think a little bit more and discuss at their tables before they come up with the correct answer. After we finished the lesson, we moved on to active practice, which has been shown to be very important by Chickering and Gamson, because having students read, write, discuss, or be engaged in solving problems is necessary as opposed to just listening. And because of this, after the interactive mini lecture, I had planned on an active practice using cutouts of different parts of photosynthesis, like the sun and plants and energy, and having them cut and paste that onto a picture, drawing me a map of how energy flows through photosynthesis. But as the lesson went on, I realized through my formative assessments that they were very familiar with this and that I should instead move on to a different active practice activity and save this for review during another lesson. So instead, they did true or false strips involving facts about photosynthesis to interact with the content, and they worked in groups so they could discuss it and use academic language, and the students who did not finish it took it home for homework. I found that they all finished the true and false, but I also had them write down 2 true and 2 false statements about about photosynthesis that they came up with on their own. And so while 92% of them did this, I got a variety of answers from things like photosynthesis energy does not come from the sun, or plants eat food as false statements, to things like photosynthesis takes in oxygen and releases carbon dioxide, or heterotrophs and autotrophs both need food for energy. So a little more detailed thinking rather than just plants eat food. But they all 92% of them came up with their own true and false statements, which took the thinking to a little bit higher. And at the end of the lesson, I assessed their mastery of the learning target using an exit slip, another form of formative assessment. The question was to describe in their own words how energy flows through photosynthesis instead of just using pictures as we had earlier in the lesson. I wanted them to use the words. And from the exit slip, I learned that only 36% of students included any information about what happened to the energy after plants harnessed it and turned it into sugar. And because of this, I will definitely use that active practice activity that I didn't use in this lesson next time so that they can see that it affects things beyond plants. And that was my defense.